Today, we're going to talk about Archimedes Principle. And I have a friend who asked me to talk about it. So this is for you, Greg. It turns out that Archimedes was a Greek mathematician and inventor, and he discovered and described the physical law of buoyancy. And what he said was, when a body is immersed in a fluid, it experiences an upward force, and that's buoyancy, and that's equal to the weight of the fluid displaced by it. Now, the story goes that he figured this out when he got into a bathtub and water overflowed the bathtub. Yeah, and supposedly he jumped up yelling Eureka and ran through the town. I don't know if that's true or not. But it's kind of a complicated principle, so we're going to break it into two parts. The first one is that when a body is immersed in a fluid, it experiences an upward force, and that's a buoyant force. Now, that's easy to demonstrate, and I want you to think about, let's think about these great big ships on the sea. They're incredibly heavy. They're held up by a buoyant force. Well, let's try and demonstrate that. I just have a beaker of water, and I have a tube here with a hole in it. Now, if I put the tube in the water, as you can see, water squirts up through the hole. Well, why does it do that? Because there is an upward force, a buoyant force. Let's show something else. Now, I have a metal lid here. I thread this lid up through the hole. I think you guys would know that if I dropped it, it'll fall. Obviously, it'll fall. I mean, everybody's going, Professor Flutterblaster, what are you talking about? Now, let's say we put it in our beaker of water. Is it still going to fall? Well, no, it doesn't. Why? Because of the upward force, the buoyant force. So, I think you guys would agree that there is a buoyant force when a body is immersed in water. Now, the second part of Archimedes' principle is that the buoyant force is equal to the weight of the fluid displaced by it, not the weight of the object. And that's an important point to remember. So let's look at that a little bit. I have two objects. One's a round ball, and this weighs 17 grams, and one's a little boat, and this weighs 17 grams. So if I re-zero it and then put the ball in there, we'll see how much fluid is displaced. $13 grams. So the ball displaced 13 grams of fluid. Okay, so let's take the ball out. There we go. And let's refill our displacement chamber and make sure it's re-zeroed. And it is. Now, remember, these two objects weigh exactly the same, but their volumes aren't the same. So now let's put our little boat in and see Now our boat displaced 18 grams. So our ball and our boat weigh exactly the same, but obviously their volumes aren't the same, and the boat displaced more water than the ball did. So what we're going to do is we're going to increase the water in our beaker till we're absolutely ready. Okay, we're obviously ready, it's overflowing. And we're going to zero it again. I'm making a mess, don't tell anyone. And it's still 0. Okay, this time we're going to take a spring scale. And we're going to weigh how much this weight weighs in air. Though it weighs 40 grams. Now, we're going to go ahead and put that on there, and we're going to submerge our weight in our water completely, and we're going to measure how much it weighs now. It weighs 20 I've got to get the right measurement here. It weighs 26 grams. So it weighed 40 and then it weighed 26 grams. So 40 minus 26 is 14. Now let's weigh how much water it displaced. 14. So, what does that tell us? That tells us that the difference in weight between 40 out of the water and 26 in the water, the 14 gram difference is the buoyant force. And that buoyant force equals the weight of the fluid displaced by the object, which 40 minus 26 is 14, and our scale also says 14. That shows that Archimedes' principle holds. So, that's Archimedes' principle.